real quick about what's going on. First off, I understand that we had a couple issues in lab this week with the quiz. That is my fault. I apologize for that. We will get to retake quiz 10 since it was something that I did not teach. Okay? And that means that you will also have to take quiz 9 in lab. Now, here's the issue. We have exams, not this coming Monday, but the following. It's exam 4. Okay? There will be no time for review in class or lab, but to make up for that, I do believe we will be having a study session this Sunday evening before the test. I will be there along with a couple of other instructors. Okay? So bring your questions. Be there as soon as I know official times and place. I will let you know. Your TAs will have an email sent out to you as well. Okay? So again, my apologies for the issues with the schedule. We're a little bit behind, and we weren't reading some of this stuff correctly with the extra holidays. We took Veterans Day off at a different time last year. Okay. Here's the other issue. We have 4 more lectures, 16, 17, 18, and 19. But we only have 3 lectures for the test. So today we're going to cover lecture 16 over voting methods. On Monday, I would like to do lecture 17 and start 18. Next Friday, we will finish all of the material for exam 4. That way, we leave for Thanksgiving break, and when we come back, you get the entire week as a review for the final exam. I will be sending out some information about practice finals for you guys. Okay? If you want to take the initiative, look up the math department website. We do have final exams from previous semesters posted, along with answer keys. So you can start looking at the finals, start working through those, getting yourself ready. That's the kind of stuff we're going to be doing the last week of class. All right, here we go. Voting methods. Now the thing with voting methods is, essentially, we pretty much know how voting works, right? You have your options for candidates or choices of different things, and you cast your vote. And typically, we're here specifically, whatever choice, whichever candidate has the most votes, wins something. Okay, there's a little bit more detail that goes into this. Okay, it's not always so cut and dry, especially with things like presidential elections, whenever you have more than one candidate or more than one option available. That's what this whole section is about. Okay. So, to start things off, say we have a ballot, or in this case, a preference ballot list. We'll say all of us are voters, and we give you your options, and then we give you a ballot. And on your ballot, you write in order your preferences. So, for this particular one, this person casts a ballot with Buchanan as their first choice, then Coolidge as their second, Adams as their third. Okay. And then we can rank them, and then for the votes, B for Buchanan, C for Coolidge, A for Adams. Pretty straightforward, regular ballot. Now, outcomes. Say we had 4 voters who ranked the candidates as A, B, C, that first column. 3 voters ranked them as Buchanan and Adams, B, C, A, and 2 people listed it as Coolidge, Buchanan, then Adams. Okay. As I said before, typically if we would look at this, we just say, oh, we look at the person who has the most votes, and then we're done. But again, so we're going to go into a little bit more detail about this. Now, majority rule. This is what we typically think of whenever we do, a vote. Like, say if we were in here and I said, well, do you want to do the homework tonight or do you want to do it after the weekend? Take a vote. You only have 2 options, right? You either do the homework tonight or you do the homework after the weekend. Well, whichever choice gets difference here. Now, monotonicity. When a candidate wins an election and in a re-election, the only changes are changes that favor the candidate, that's an important thing, then that same candidate should win the re-election. The first election is what we call the straw vote. So let's look at this table. The 5 and the 4 across the top, the number of votes, that would be an example of the straw vote. That's your first election. Okay, well, according to the first election, that would be 5, right? And then say for the second election, things change, and it ends up being 6-3. So it is monotone. The same candidate won in the straw vote and then in the second election. Okay, that's why it's called the monotonicity. Now, majority rule, okay, so we're talking about the majority method for voting. It is monotone, and the only method for 2 candidate elections that is monotone. It also treats your voters equally, and it treats both candidates equally. Now again, here's the key thing. We're only talking about 2 candidates. We're going to see a couple versions where you have more than 2. That's monotonicity. Now, let's talk about majority rule when you have more than 1. Okay. To win votes by majority rule, a candidate must have at least 5 or more than half of 9, for this particular example, first place votes. Here's why. Look across the top for the number of votes. 4 people voted that particular way in the first column, 3 people for the second column, 2 people for the third column. That means there was a total of 9 votes. Okay. So for majority rule to work, what do the candidates have to have? At least 4.5, which is impossible since we're talking about people. So at least 5 votes or more for one candidate. Well, let's take a look. For candidate A, they won, okay, we're only looking at this first row for first choice. Candidate A got 4 out of 9 votes. Candidate B got 3 out of 9 votes, and candidate C got 2 out of 9 votes. So again, in order to win according to majority rule for more than one candidate, that person would have to have half the votes or more. Half the votes of 9 would be 4.5. No one has 4.5 votes, or more than 4.5 votes. So this is why majority rule produces no winner in this case. There's a difference when you have just 2 candidates or more than 1 candidate with majority rule. So there's one method. Now we have what we call plurality. For this one, we are only looking at the first place votes, and the candidate with the most first place votes wins. So this is more along the lines of what we're used to seeing whenever we talk about voting. listed as second choice, but if you get rid of candidate C, move him up to first, candidate A would have 4 votes, but then B would have 3 votes, and 2 votes, you'd have 5. Makes a difference. We'll see why here in a bit. This is what we call the irrelevant alternative criteria. For irrelevant alternatives, think of words. You have another candidate, and it should be irrelevant, whatever the results are for that particular candidate. Okay? The voting system is said to satisfy the irrelevant alternative criterion if the winner under this system stays the winner if you cut out any of the other non-winners. The winner stays the winner when you cut out any of the irrelevant candidates. Make sense? See what I'm saying here? Let's take a look. So we were just talking about plurality. There's the same chart. According to plurality, we said A is the winner. Okay, fair enough. Well, let's cut out the biggest loser, shall we say? According to the first choice, C had the fewest votes. Let's cut out all of the votes for C. Okay, so C drops out. Now, like we just said on the previous slide, bump up the votes in the second and third column. Okay, so now it looks like this. We got A, then B, and then B, then A, and then another B, then A. So this means that B is the winner if we talk about the plurality method once you drop out C. This tells us that plurality voting doesn't satisfy this irrelevant alternatives criteria. Let me just use a different highlighter there. Because the whole point with the irrelevant alternatives is when you cut out the biggest loser, you should still have the same winner for majority, or not majority, plurality. Okay? So in this case, it didn't work. Next method, head-to-head winner. Candidate is a head-to-head winner if he or she beats all other candidates by majority rule when they meet in a one-on-one match. So we're applying the majority rule to 2 candidates at a time when you have multiple candidates. That's what's going on with head-to-head. Right? To decide if a head-to-head winner exists, as we said, we're going to match up every candidate on a one-to-one basis. And the only problem here is, again, there may not exist a head-to-head winner. You could have a tie. Let's see this in action. So again, back to our chart with our ballots. We have to choose 2 candidates at a time. So let's start with candidates A and B. So if we compare just candidates A and B, don't look at any of the C's, right? Cut out all of the C's. According to the first choice, A would have 4 votes. B would have how many? Remember, you're cutting out the C's and you bump up the other values. B should have 5. Cut out the C's, right? So in that last column under 2 votes, ignore the C, bump up candidates B and A. So B has 3 votes according to the second column. If you cut out the C, B will have 2 votes in the third column. Okay? So that's A versus B. Let's look at A versus C. All right? Candidates A and C. So this time we're going to cut out candidate B. All right? So ignore still left with 2. Now, out of these 3 possibilities for our head-to-head vote, in the first head-to-head match, B won. In the second match, candidate C won. But in the third match, B won. Again, since B won the most head-to-head matches, B is the winner. So for a head-to-head match, I'll abbreviate as H2H. Okay. Now, does the same candidate win using the head-to-head comparison and by using the plurality method? No, because remember A won by plurality. With the head-to-head method, B won. No. Let's take another look at this head-to-head method. Have another chart. Suppose we have a 9-member committee, and they need to elect one of 3 alternatives, person A, B, or C, and their preference schedule is given below, or their preference ballot. This is how they lined up everything. Who is the head-to-head winner? Same layout. So let's start with candidate A versus candidate B. So ignore all of the C's. So let's cut him out, cut that one out, cut that one out. Candidate A has how many votes for first choice if we cut out all of the C's? 6. In that last column, you've got to bump up the A and the B. So A becomes the first choice. So there's another 2 votes there. So A has 6 votes, and B has 3 votes. Still with me? Yes? Absolutely. So, for head-to-head, remember we're only considering 2 candidates at a time, right? So we cut away the third candidate that we're not looking at. He's not part of this head-to-head competition. In this case, we're cutting out candidate C if we're doing A versus B. So that's why I crossed out all of the C's. And after you cross them out, you move the other letters up. So in that third column, A becomes the first choice when you cut out C, and B becomes the second choice. Everything gets moved up. In the second column, the C got cut out, so A is the new second choice in the second column. Okay? We're cutting out the candidate we don't worry about. So there's our first one. The next one, let's do A versus C. Okay? So for this one, we're going to cut out candidate B. So I'm going to cross him out, cross out all of the B's. And again, move up your values accordingly. So for A versus C, candidate A has, let's see, according to the first choices, we've got 4 votes in this first column, and A isn't the first choice in any other one. So A only has 4 votes if we cut out all of the B's. Candidate C, however, okay, candidate C is not the first choice in the first column, but in the second column, he is the first choice when we cut out B. And in the third column, candidate C is also the first choice. So candidate C now has 5 in this head-to-head match. So we did A versus B, A versus C. The last option is to do candidate B versus candidate C. Alright, so for this one, cut out all of the A's in the first column. B is first choice also in the second column. So that means for this match, candidate B has 7 votes. And candidate C is the first choice only in the third column, so candidate C only got 2 votes. Okay? So let's see who won what, how many times. In the first match, candidate A won 6 by 30. In the second match, candidate C won. And in the third match, candidate B won. So this is that problem that I was talking about. Sometimes you're going to have a tie between everyone. So in this case, there is no head-to-head winner. It's a tie all the way across the board. Next up, the board account method. For this method, you assign point values to your candidates in the order that they were listed according to your ballots. So the absolute last place candidate only gets 1 point, the place immediately above them gets 2, the next place up gets 3, so on and so forth all the way up the list. Total your points for all of the voters. Candidate with the most points wins. Relatively straightforward. The math, however, hang with me, gets a little funny. The point total, that final total when you add everything up, that is the BORDA score. Now again, there's always some kind of issue here. This does not satisfy the irrelevant alternatives criteria. So that means, say you have your straw vote, your first election, and you have a particular candidate who wins. Well, remember, if you do the irrelevant alternatives, that same candidate should win when you cut out the biggest loser of that election. Doesn't work with this method. Okay? Point values get a little bit messed up. Let's look at an example. All right, here's our chart that we've been working with. We have 4 voters that voted that way in the first column, 3 voters for the second column, 2 voters for the third column, right? If a candidate was placed as a third choice, remember that's the lowest possible, they only get 1 point. The next place up gets assigned 2 points. And then the next place up gets another point, so 3 points. Now we got to do the calculations. Let's look at candidate A. For candidate A, 4 people voted for candidate A in the first column. And candidate A was the first choice, so they get 3 points for that. In the next column, 3 people voted a particular way for that column, but candidate A was the last position in the second column. So for that one, candidate A only gets 1 point. In the last column, 2 people voted a particular way for that third column, right? But again, candidate A was the very bottom choice. So for the third column, candidate A only gets 1 point. This is what I was saying when it gets a little bit weird. Total this up. 4 times 3 gives us 12. 12 plus 3 gives us, what, 15? 15 plus 2 gives us a total of 17 points. Let's go through that one more time. All right. We're going to start by looking at candidate A. And we look at the position of candidate A in each column, right? And we assign That's where the 3 comes from. And now you look at the position of candidate A in the second column. In the second column, A was the 3rd choice for the people. Well, if you are the 3rd choice, you only get 1 point. That's why it's 3 times 1 for that second one. Go over to the 3rd column. 2 people voted a particular way for that 3rd column. So there's a 2. But again, look at the position of candidate A. A is in last place. Since A is in last place, A only gets 1 point. Add it up. So those are point values for candidate A. Now let's look at B. Same idea. Look at the first column. 4 people voted a particular way for that first column, so we start with a 4. But B is the 2nd choice for the first column, so he only gets 2 points. For the next term, we're looking at the 2nd column. 3 people voted a particular way in the 2nd column. But how many points does B get? 3. In the 2nd column, B was the first choice for those voters. So he gets all 3 points. In the 3rd column, only 2 people voted that particular way. But B is in the 2nd position, so B gets 2 points. Have we seen the pattern yet? Starting to get this? So add it up. See, 4 times 2 gives us 8, plus 3 times 3 gives us 9, 8 to 9, what? 17, plus another 4, 21 points. And then last but not least, candidate C. For the first round of voting, or first setup, 4 people voted a particular way. Candidate C gets how many votes for the first column, or how many points? 1. He's in last position. 2nd column. 3 people voted that way, but he's in 2nd position. I heard someone say it. 2 votes, because he's in 2nd position. And then the 3rd column. 2 people voted that way according to the 3rd column. He gets 3 points because in that column he is first choice. Okay, add it up.
16.
You get 4 plus 6 plus another 6. 16 points. So according to the board account method, candidate B wins. It's a little bit tedious. Good old Heisman Trophy. Board account.
Why in the last one for C, you gave him 3 points?
Okay.
I don't see that.
So let's look at candidate C. For the first column, 4 people voted a particular way, but C is in 3rd position, so he gets 1 point. That's 4 times 1.
Oh.
2nd column, 3 people voted that way, but C is in position 2, so he gets 2 points. 3rd column, 2 people voted a particular way, but C is in 1st place for the 3rd column, so he gets 3 points. Okay. Other questions over this one? Like I said, it's a little tricky, so if you have questions, ask them now. All right. Now, let's change things up a little bit. Plurality with elimination. So we're going to combine a couple ideas here. We are going to eliminate candidates based on the number of first place votes. Well, let's take a look. Look at your first place. Who has the fewest number of votes in first place? So there's 7 votes, 5 votes, 4 votes, 1 vote. Who had the fewest number of votes according to first place?
D.
D. All right. So plurality with elimination. So eliminate D has the fewest first place votes. D is eliminated. Remove D from the chart and move everybody else. Okay? So on the next slide, let's do a little bit of a rewrite here. Okay? So after we eliminated D, C. That leaves us with, in first place, it should be A, and then B, and then C, right? We're cutting out all the D's. And then we've got C, then A, then B, and then B, C, A, and then the last column, A, B, C. Okay, keep going. Keep eliminating the biggest loser. So the one we cut out this time has to be B. Okay, just look at the first place. Look at first place. Who has the fewest first place votes? B. B. A got first place in the fourth column as well. So he's got 8. Right? B has 4, C has 5. So cut out all the B's. And let's do another rewrite. So now we're down to first and second place, right? We are left with candidate A and candidate C. Second column, candidate C and candidate A. Third column, C and A again. And last column, A and C. And once again, cut out the biggest loser. A has 8 first place votes, but C has 9 first place votes. So this time we have to cut out A. So C is our winner with the method of plurality with elimination. And as usual, we do have that drawback. This system does not satisfy monotonicity. So again, if you did a straw vote or an initial election, one candidate would win, but then you apply this method, you have a completely different winner in the re-election. It doesn't always work for monotonicity. So let's show why. So again, when a candidate wins an election and in a re-election, the only changes made favor the initial winner. Same candidate should win, right? That's what we were talking about. Monotonicity. Here's our chart. According to our first round of elimination, you cut out candidate D. Right? Look at your first choice. Candidate D has the fewest votes, so you cut him out first. You bump everything up. Then you have to eliminate candidate B once you move everything up. Okay, take a look at it for a second. That leaves us with candidate A, because then A would have 13, right? 7 votes or 6 votes, 13 votes for first place, and C would only have 8. Right? You bump everything up once you cut out those other values. Okay. So A wins this round. This was the first election. Now we're going to look at what happens if we change things up a bit. Say we did a second election and a couple of the results changed. All right. So the top chart, that was the initial one. That's the one from the previous slide. The second one, look what happens. They moved A into first position, the second chart. All right, follow the same process. You start by eliminating the biggest loser in the second chart. Let's see. A would have 10 votes, B would have 6, and C would have 5. So you cut out all of the C's first. Okay. Then B won this one. How are we doing so far? Sort of. If you rewrite these tables out for yourself and do the elimination by hand, the whole point of this was, in this side, the original first vote, A won. But in the second vote, right, when you use the second chart down here, B won. So plurality with elimination does not give you the same winner if you have multiple elections. It does not satisfy monotonicity. That's the whole point of this example.
So are you doing the same thing?
Yes. Yeah. So we had, in this particular example, we have 2 elections. That's what's going on. This chart is from the first election. First election, candidate A, he won. On the next slide, the top one is the original chart from the previous one. And the second one, we made a change. We had people vote again, and a couple people changed their votes. That's what happened with the fourth column and the second chart. Follow the same method, plurality with elimination. Cut out the biggest loser, but remember, you want the same candidate to win as the first election. Same candidate didn't win the second one, so monotonicity does not hold. You don't have a monotone candidate for all of your elections. That's what's going on. Plurality with elimination does not have monotonicity. You will not always have the same result. Possible test question. I'll give you a second to write this out. We've got 22 voters, and they want to figure out if they're going to the beach, the mountain, or the zoo on a field trip. And they set up their ballots like so. So for this one, we're doing plurality with elimination. Siri, have a fun fact for us today?
What's the tallest building in the world?
Hello? Okay. So just a couple more things to talk about. Fairness in voting. Fairness. There are 4 criteria that we've talked about for voting.